In this video, Work and Energy Lesson 3, we will solve the fence problem, and at the same time we're going to have a few roller coaster questions. So the fence one is the one that students usually say difficult question, and the roller coasters are usually the easier ones. So let's look at the first question in this video. 1.2 kilogram mass is projected from the ground level with a velocity of 30 meters per second at some unknown angle. I think they give you angle later, above the horizontal. The short time after being projected, the mass barely clears 16-meter tall fence. Disregard the air resistance and assume that the ground is level, so the potential energy on the ground is 0. What is the kinetic energy of the mass as it clears the fence? So let's calculate the kinetic energy of the mass as it being shoved. So initial kinetic energy. So I'm going to say kinetic energy initial is equal to 1/2 the mass and initial velocity squared. I get 540 joules, so 1/2 the mass and initial velocity squared gives me 540 joules. So this number is going to be 540 joules, and the potential energy initial is 0 because it's the ground level. So the potential initial energy is 0. Then because the fence is 16 meters, then it has some potential energy over here. So the potential energy is mgh. Mass is 1.2, h is 16, and g is 10. So that gives me 192 joules. 192 joules. And because the total energy of the system is 540, I know that the kinetic energy at the top of the fence is equal to 540 minus 192 will give me 348 joules. They don't tell me it's the fence on the way up or on the way down, and they don't tell you that it is the maximum at the maximum position of the ball. So it could be on the way up or on the way down. So this potential in kinetic energy is the same no matter whether the ball is on the way up or on the way down. Then I can calculate, so let me see, the kinetic energy as it clears the fence. So this one is 348 joules. And then what is the velocity of the mass when it passes over the fence? So the kinetic energy is equal to 1/2 the mass velocity squared. So I can figure out the velocity of the ball as it passes over the fence. So I'm gonna make it like this. This velocity, it's not horizontal, it's not vertical, it's the actual velocity. So I'm gonna plug in the numbers and find that velocity. I get 24 meters per second. So I figure out this velocity, 24 meters per second. I'm clearing the stuff so it doesn't get too complicated. And we can also do this initial velocity. So this was your initial velocity, which is 30 meters per second. And now you found the velocity is 24 meters per second. So this one is 24 meters per second. Okay. And so this one is 24 meters per second. I'm going to write my answers as I'm answering them. If the angle was 53 degrees, how far is the fence from where the mass was projected? Also, if this is 24 meters per second, then that one is also 24 meters per second because it has exactly kinetic energy. Same kinetic energy. So this one is also 24 meters per second. And when they say how far is the fence, it could either be this position or that position, whichever is, this one or that one. on the way up or on the way down? So we do not know, so we will have two answers. So if the angle was, they tell you if the angle is 53 degrees, then that gives me horizontal velocity and vertical initial velocity. I can figure out those right away. So the horizontal is 30 cosine and vertical is 30 sine. So horizontal is 18 meters per second. 18, and that horizontal doesn't change. The horizontal velocity stays the same. So all the way until it hits the ground, it's still going to be 18 meters per second. And the vertical velocity is 30 sine. And the vertical velocity comes out to be 24 meters per second. So now when I am passing over the fence, I am looking, let me make maybe this velocity horizontal blue. So when I'm passing over the fence, this velocity is the same, 18, 18, and 18. So if this is 18, I'm gonna redraw that triangle. So I have this velocity is 18 over the fence. This velocity is 24, so this is 24. This one is 18. You can use Pythagorean theorem to figure out, let me choose maybe a different color, to figure out this velocity. So if I use Pythagorean theorem, it's 24 squared minus 18 squared and then the square root of that. 15.9, so 15.9 meters per second, or I can say 16 meters per second. So the velocity vertical right here as it passes over the fence is 16 meters per second. So it went from 24 meters per second to 16 meters per second. The time it's going to get to the fence is change of the vertical velocity over the acceleration, because it loses the velocity vertical. So the change of the velocity is 16 minus 24. Final is 16. I'm rounding my 15.9. Minus 24. And divide by negative 10. It's a deceleration. So that will give me 0.8 seconds. So the velocity to get to the first fence, or on the way up, is 0.8 seconds. So right here I have 0.8 seconds. Now the time to get to the, let me erase this. The time to get to the middle, to the highest point, the time to get to the highest point from this vertical velocity of 24 meters per second, so that will be 2.4 seconds. And to the time to fall down, another 2.4 seconds, so that is 4.8 seconds. So in 4.8 seconds, the the mass will fall down. So I'm looking at it from this 24 meters per second velocity. So the change of the velocity of acceleration gives me the time. And since it is 16, velocity vertical here, 16 meters per second. Oh, actually, I don't need this one. So it is still 16 meters per second, but I just don't need this part. I'm going to look at it here. This distance is exactly the same as this distance, because it's a parabola. So I'm going to go back 0.8 seconds, and then it will take 4 seconds to get here. Now, the questions that they ask you is, well, actually, how long does it take the mass to stay in the air before it falls on the ground? So I can answer that question now. I will say 4.8 seconds. And if it is, how far is the fence from where the mass was projected? That's the one that I'll have to find out right now. So if I'm looking for the mass the distance to the mass. So this distance is equal to vertical velocity, which is 18 meters per second, horizontal velocity, which is 18 meters per second. It's Vx times the time, and the time is 0.8 seconds. So the fans could be at this distance, which is 14.4 meters, or the fans could be at this distance, which is the same horizontal velocity that doesn't change, times 4 seconds, gives me 72 meters. So my answer, if the angle is 53 degrees, how far is the fans from where the mass was projected? So I could say it is 14.4 meters or 72 meters, one of those two, whether it's on the way up or down. And what is the maximum height that it reaches? So if I'm calculating the maximum height, I'm going to choose a different color. If I'm calculating this maximum height that it reaches, I need average vertical velocity times the time to get to the top, which is 2.4 seconds. And average velocity, it starts with 24 meters per second vertical velocity, and it loses all its vertical velocity all the way at the maximum position. So the average velocity is 12, the time is 2.4, so the height is 28.8 meters. So the final answer here is 28.8 meters. You probably want to watch this video a few times because I know there's a lot of information. So watch maybe a few times, and then you can change the numbers and try to solve your own question. So you can say that the mass is 2 kilograms, the initial velocity is 20 meters per second, and the angle may be 30 degrees. And the fence maybe is only 2 meters tall. So you can change the problem and try to solve it, and you can always come to me and talk to me and see if you got the right answer, whether you're solving this question. And I believe in our online lessons you have a few questions like this, so you can practice and see whether you solving it correctly or not. So we're starting this video with two probably somewhat, the first one was challenging question, but the second one is somewhat challenging question. So let's write, underline everything that is given in this question. So what is the velocity of the car after being catapulted into motion at point A and then B? Catapult system propels the car across a distance of 12.5 meters by the net force of 8.8 kilonewtons. So the information that is given, the distance is 12.5 meters, the force, the net force is 8.8 kilonewtons, and initial velocity is 0 meters per second. It starts from rest. So if you have this distance and the force is acted over this distance, then the work done by is the force, which is 8,800 times the distance, which is 12.5 meters, and that number is going to be equal to 110,000 joules. And this much energy is converted into, or this work was done to give this much kinetic energy to the cart. So the cart has no energy, kinetic energy at first, and then the force is pushing the car is accelerating and gets to so much energy was put into the car, so that is the kinetic energy of the car. And the kinetic energy is equal to 1/2 mv squared, and this is velocity at point A. So I can figure out right here the velocity at point A is equal to, and the mass is given 3,000 kilogram. So I'm going to multiply by 2, 110,000, I'm going to multiply by 2, divide by 3,000. So v squared is equal to 73.3, and when I take the square root of that, I get 8.6 meters per second. So this is the velocity at point A. But it also has potential energy and kinetic energy. So the kinetic energy at point A, is this much, because the work turned this into the kinetic energy of the car. And the potential energy at point A is equal to, so I'm going to calculate here. Potential energy at point A is equal to mass M, G, and H is 95. So let me see what this number is equal to. I get 285 and 4 zeros, so that's 285 and 4 zeros joules. So that is the potential energy at point A, and this is the kinetic energy at point A. So this is your total energy in the system, and total energy of the system is going to be conserved. So at point B, you will have exactly the same total energy. So your sometimes they call it mechanical energy. So the mechanical energy of the system, kinetic and potential together, is 110,000 and 2,850,000. And so that is equal to, so the total energy of the system is 2,960,000 joules. So that is the total energy. So this total energy should be the same at B. So at first I'm going to calculate the potential energy at B. So the potential energy at B is equal to mg this h. So if I plug in my, let's do it here. Potential energy at B is equal to the mass, G, and H is 65. Gives me 195 and 4 zeros of joules. So if this is how much potential energy at B, so I have potential energy at B, then the rest of it is the kinetic energy at B. So to find the kinetic energy at B, I subtract from mechanical energy the total energy of the system, my potential energy at B. And that will give me 101 and 4 zeros joules of energy. And now that is equal to 1/2 mass V at B squared. So the velocity at B will be equal to 25.9 meters per second. So we lost height. So we lost the potential energy when we went from A to B. And because we lost the height, we lost the potential energy, and that potential energy went to the kinetic energy. And so now at B, the velocity is higher. So at A, we had the velocity of 8.6 meters per second. And then at B, we have almost 26 meters per second. So here is one more roller coaster question. We have a roller coaster begins at rest, 120 meters above the ground, and at point A, as shown. Assume that the energy is not lost from the roller coaster to the friction and air resistance sound or any other processes. So the radius of the loop of the first loop is 40 meters, and find the speed of at point B. Okay, the loop, so this means at the D point. So the radius of this loop is 40 meters. And we have to find the speed at B, C, D, E, F, H. And at point G, we want to find the speed of the roller coaster is given, we want to find the height. So let's calculate. Our first thing is the potential energy at A, because that's going to be how much total mechanical energy we have. So that is the mass, G, and H is 120. So that gives me, they don't give me the mass, but probably I don't need it. So I have the potential energy is equal to, I'm going to keep M, and then G and 120 gives me 1200. So instead of this part, I'm just going to write 1200 M. So I have 1200 M joules of energy. And the kinetic energy at A is equal to 0 joules. So this is my total mechanical energy. At every single point, I should have exactly the same amount. And mass M is not given. So at B, now potential energy at B is equal to M, not given, G, and H is 60. So that is 600 M. So this is 600 M. And if I compare my initial and final potential energy, I see that mechanical energy should be conserved, but I'm missing 600 AM joules of energy. So I know my kinetic energy right here is equal to also 600 M, because their total energy should be equal to 1200 M, where M is the mass. So from here at B, I can calculate the kinetic energy at B, which is 1/2 the mass V squared at B. So I have 600 times the mass is equal to 1/2 mv squared at B. This is why I don't need mass, because mass and mass can be cancelled. And I have the velocity at B is equal to the square root of 1200. I get 34.6 meters per second. So that is the velocity at B. Now I'm gonna look at C. The same, I'm gonna say the potential energy at C is equal to 0 because it doesn't have any height. That means the kinetic energy at C is equal to the total energy mechanical, which is 1200 M. So that is my potential and kinetic energy at C. C is all the way at the bottom. So we did B, we did A, and now we're at C. So from here, I can say that kinetic energy at C is 1/2 mv at C squared. So I have 1200 mass is equal to 1/2 mvc squared. The mass and the mass cancels, so V at C is equal to the square root of 2400. I get 48.8. I'm gonna round it to 49 meters per second. Then the next one is at D. D is radius is 40 meters. That means D is 80 meters above the ground. So I'm gonna calculate the potential energy at D. So the potential energy at D is equal to, it is M, G, and H So mass is not given, g is 10 and h is 80 meters above the ground. So that is 800 times the mass, and the kinetic energy at d is going to be equal to, so the total energy of the system is 1200 m. So that means this one has to be 400 m, because the total must stay 1200 m. So from here I can see that kinetic energy, which is 1/2 mv squared, is equal to 400 m. M and m can be cancelled, so the velocity at d is equal to the square root of 800. 28.3 meters per second. I'm gonna skip my calculations for E. So at E you will get the velocity at E. You can check yourself. The velocity at E, because it's just repetition. The velocity at E gives me 40 meters per second. And the velocity at F the same as at C. So the velocity at F is the same as the velocity at C, which is, we had 49 meters per second. And then they want you to find the height. I'm going to do the G part. They want you to find the height at G. And they tell you that at G, the velocity is 20 meters per second. So if the velocity is 20 meters per second at G, then I have kinetic energy at G is 1/2 the mass and velocity squared. So that's 400 divided by 2, that's 200 m. And the total energy of the system should be 1200 m, so that my potential energy at G is going to be 1000 m, and equals to m, g, and h. And I'm looking for the height at point G. So m and m again can be cancelled, so the height is 100 meters for that part. And velocity at h, because h and a are the same heights, so the velocity is going to be equal to 0 at h.